Okay, everybody. So today we're going to be talking about reflection, specifically reflecting shapes onto themselves. Okay, so just going to review a couple of things before I do this. These are things you guys should have learned before, but first of all, I've got these random shapes, and we're just going to draw in a line of symmetry. Okay, so most shapes have some kind of line that if you were to like cut that shape in half and put it on top of itself, like it would be the same thing, right? A line of symmetry, like it would be the exact same thing on either side of the line of symmetry. Now, squares have lots of lines of symmetry, right? They're symmetrical both horizontally and vertically, right? So if I cut this in half, like it should be like the same way either side of that shape, or if I did it horizontally as well. But squares are also symmetrical if you cut them in half diagonally, right? So there's a lots of line of reflections or line of symmetry with squares. Now here we have like a parallelogram. It doesn't have a lot of lines of symmetry. In fact, I can only kind of see one, and that's just like a diagonal line that kind of cuts it in half. That's the only way that it would be symmetrical because I can't cut it horizontally, um, and I can't cut it diagonally. So yeah, that's the only line I see. Rectangles just have the two. They have the horizontal and the vertical. I mean, it should be halfway. That's not quite halfway, but you get the idea, right? Diamonds are basically just sideways squares, but this one isn't quite a perfect square, so it only has the two lines of symmetry there. Could I cut it? Yeah, I could cut it diagonally, but it's just not as nice. So yeah, I guess it's the same as a square. Has all the things. Okay, and those are the shapes that you really have to worry about. There will be triangles. If you have a triangle, like its line of symmetry basically just goes right down the middle, like that, right? So from the point to like the side, I think it's really its only line of symmetry. Um, if I did it this way, it depends on the triangle. If it was an equilateral triangle, you could do it, every direction. But you're not going to have equilateral triangles on this assignment. So basically, it just has the one line. Okay. All right. Then we're going to be doing these on graphs. So we need to kind of just review what our lines are that we can draw that um, can do the horizontal and vertical lines and stuff like that. Okay. So y equals a number is either your horizontal or vertical line, right? What it's saying is y is always negative 3, no matter what x is. If y is always negative 3, like here's negative 3 on the y, right? If y is always negative 3, like all these points have a y value of negative 3. If I connect them, I end up with a horizontal line, right? So y equals a number is just a horizontal line, okay? X equals a number, same idea. X is always 1, no matter what y is. So if x is 1, then look at all these points that have an x value of 1. If I connect them, I get a vertical line. Okay? So x equals is vertical, y equals horizontal. What if it's x equals 0? Well, x is 0 right here at the origin, right? It means everything like on that line going up and down, x is 0. So x equals 0 is just another way of saying the y-axis itself. Okay? So if you have something that has a line of reflection on the y-axis, you would write that as x equals 0. Not the y-axis, you'd write that as x equals 0. Okay? Same idea, y equals 0 is just the x-axis. Okay? So you'd write it as y equals 0. Okay? Then we have our diagonal lines, right? Y equals x, we have both variables, which means it is absolutely going to be diagonal. Okay? That just means it has a slope of 1 and it has a y-intercept of 0. So you'd start at 0, you'd go up 1 over 1. And these are the diagonal lines that basically cut these square graphs exactly in half diagonally. Okay? And,
I'm hoping this is the last interruption.
Hold on, I'll pause this.
If we could please.
All right. Love me some announcements during the videos. Okay, so there is y equals x, right? It's just that line right there, that line that goes straight, cuts that square graph exactly in half. Y equals negative x, same idea, except for it's a -1 slope, so it is going down. I could draw a straight line. I can't. Okay, it's that one that's going down one, right one. Okay, so y equals x is the positive slope, y equals negative x, negative slope. Okay, now let's see how this actually works. So I'm going to zoom in even more here so we can better see what's going on. So here I'm given some shapes and I'm being asked to identify all the lines of reflection that would reflect that shape onto itself. So basically I'm trying to write down all the lines of symmetry for this shape. And we just have a square. It's right here. I don't know how easy it is to see on the screen there, but if you're looking at the paper, it's not hard to see. But that's what I'm looking at, is that square right there. Its center is right there in the origin. So if I'm looking at this, a line of reflection reflected on itself would be exactly halfway, right? So all I'm doing is I'm looking for the halfway point to reflect it, and it should reflect onto itself, okay? So right here, it is being reflected, or like if I reflect right there at the x-axis, that would reflect onto this, because it is 4 high, right? That's halfway. So it would reflect right there onto itself. If I reflect this image over the x-axis, it would actually look the exact same. It would not change. I mean, if I labeled these points, like they would flip sides, but the shape would still be on top of all the same points, okay? So y equals 0, because that's what the x-axis is, right, is one line that I could use to reflect it onto itself. Now, it's a square, they all have equal size, right? So it's also for this way. So if I reflect it across the y-axis, it would also reflect onto itself. So x equals 0 also works, okay? Now, squares also can have a line of symmetry diagonally as well. Now, this square, if I draw in the y equals x diagonal, it would cut that square directly in half because it's right there centered on the origin, okay? While y equals x also is a line of reflection for that entire graph square as well, if you look at the entire graph square. So all I did was minimize that. So y equals x also reflects it, as well as y equals negative x. Okay? All right. Let's try another one. So this next one, we have a triangle. So let's look at this. We want something that will cut this triangle in half, but I'd have the same shape on either half. Okay? So if I look and drew a line this way, it would not be the same. It would just be like this little skinny piece and then kind of a normal triangle right there. I also can't do it from there. The only thing that makes sense is if I draw this line going right there, right? Kind of like what I showed you with the triangles. There's just that one line. Well, if I look at this line, what is this line? If I continue it, what is this line? Hey, look. It is our diagonal line that cuts this graph in half. It's y equals x. That's my only line of reflection that would reflect that shape onto itself. If I reflected this triangle over y equals x, it would literally be the same triangle. Okay? Because again, to reflect, I would count to the line horizontally and then vertically after the line. So if I count to the line, 1, 2, 3, 4, and then vertically 1, 2, 3, 4, look, the point ends up on the same point on the triangle. And this point's already on it, and these 2 points would just flip if I reflected it. Okay? So y equals x. And then here we have a rectangle. Rectangles only have that horizontal and vertical. So this is an interesting one because it is 3 high. Okay? So that means that halfway would be at 1.5. So the horizontal line is a decimal that would cut this in half. It's just halfway. So y equals 1.5 would be one line. And then it is -4 and 5. So that's 9. So it's vertical and it's also going to be a decimal. So at about 0.5, right there, would be the vertical line of reflection. Again, you just go halfway on rectangles. Halfway horizontal, there's your line. Halfway vertical, there's your line. Okay? So x equals 0.5 or 0.5, however you want to write that. And that would be your two lines of reflection that would reflect that rectangle onto itself. Okay? Let's try one more here. So, well, let's do a few more. So here we have another triangle. Okay? So same idea. They really have the one line of reflection. And just looking at it, you can tell it's going to be the diagonal again, right? It's going to go cut this triangle in half this way. And I can't really do any other lines of reflections that would reflect it onto itself. So, but this is not the same line of reflection as the other triangle, right? This line has a negative slope. It's going down from left to right. So this is the y equals -x. Okay? That would be your line of reflection there. Okay? Then, and this one's kind of hard to see on the screen, but it's this rectangle right here. Okay? So again, I'm looking for the halfway marks on the rectangle. So halfway, it's 4 across, so I'd go to 2. There is your vertical line of reflection. So again, that is just x equals 2. It's right there on 2 on the x. Vertical lines are x equals. And then horizontally, it goes up to 6, so halfway would be 3. So right here at y equals 3 is your other line of reflection that would reflect that shape onto itself. Okay? It's not tough, especially with the squares and rectangles, because you're basically just going halfway and drawing a horizontal and vertical line. Okay? And then let's look at one more. This almost actually looks equilateral, but if I look at this, it is 10 units long, but it's only 6 units high, so it's not equilateral. So it's only going to have one line of reflection. So if I try drawing a line from this point, it's not going to be symmetrical, right? Because that's what I'm looking for, is a line of symmetry. If I draw a line from this point, it almost looks symmetrical, but it's not quite. Okay? The only one that's going to be symmetrical is the one coming down from that top one. Then we got the same triangle on either side, right? So my line of reflection is this vertical line right here, which is at -3 on the x-axis, so x equals -3. And that would be your answer. Okay? So all you're doing is trying to write, this is your answer right there, right? That's all you're doing. Okay. If you have any questions, comments, concerns, ask your teachers. We're here to help. We want to help, and I'll see you guys out there.